Hello, good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning. So, all of you are now very much aware about your syllabus, no? For the midterm exam. Probably this is the last class before exam, midterm exam. So, you are just a minute. So, what do you like? Today I will start new things uh, or I can give you a revision.
Sir, revision, I think revision would be better.
Sir, revision, please.
Okay. Okay. So, okay. So, one of the application is the curvature. And you know that what is the curvature definition is known to you. And one thing you must remember that there are some methods to determine the curvature and radius of curvature. And curvature and radius of curvature is inverse of each other. And one more thing that this is the length. Curvature, radius of curvature is the length. So at if at any stage it is found negative, then you will consider only the positive value. Okay. So curvature is this is the formula for the curvature, ds by d psi. And look at this here, the radius of curvature is the inverse ds by d psi, ds d psi. So remember this, it may be useful sometimes when because you know that you know only the formula for the radius of curvature. So formula for the radius of curvature. So if you need to find the curvature, then first find the radius of curvature and take the inverse of this. And these are some formulas, as I told you earlier, that mm, for three types of three formulas or four formulas I have discussed. One is the for the curve like this, y equal to fx, Cartesian equation, and in this case the radius of curvature is remember this, that 1 plus y1 square whole to the power 3y2 by y2, provided y2 not equal to 0, and if at any case y2 equal to 0, then you may use this formula, 1 plus x1 square whole to the power 3y2 by x2 not equal to 0, and in the previously here y2 not equal to 0. And for the parametric equation, if you consider x equal to phi t, y equal to psi t, then this is the formula for the radius of curvature. Also, look at this, even if it is a parametric equation, then also you can use the this formula also, because you know that dx dt dy dt is from where you can find the dy dx. But if you can remember this formula, then you can directly use the parametric equation for the radius of curvature. And polar case, this is the formula. Sorry, no, this is the formula. This is the formula for the radius of curvature. And sometimes when someone forget the uh, formula for the polar equation, sometimes it is found that they convert it to the Cartesian equation, then use the formula. But always it is not convenient. It may be difficult to convert the polar equation to the Cartesian equation in some special cases, and also it will take time. So I would suggest to at least remember the 3-4 formulas for the radius of curvature, so that you can at least based on your given problem, you can use the formula to uh, evaluate the radius of curvature. And here it is, this is also very important formula known as the Newton's formula. This is the most simplest formula. That's why sometimes we prefer to use the Newton's formula. Just find the tangent, check whether it is passes to origin or not. If it is passes to origin, then check the tangents at the origin. I told you how to find the tangents at the origin. It is the lowest degree term equated to 0 gives the tangent at the origin. And then if just remember, if x is the axis of x is the tangent at the origin, then rho equal to this, limit x tends to 0, y tends to 0, x square by 2y. And if y is the tangent at the origin, y axis, then y square by 2x, and neither x nor y is the tangent at the origin, then if it is of the form ax plus by equal to 0 be the tangent at the origin, then the formula is this, rho equal to half root over of a square plus b square, x square plus y square by ax plus by. This is the general formula. From here also you can find for x axis, for y axis, setting other 0. So this is also important formula. So you should remember the formulas at least. So I think then it will not be a problem to evaluate the radius of curvature, and you have to decide which formula to be used. Because suppose if I give you an example like this, now you have to decide which formula to be used. most direct formula is the this formula, y rho equal to this. Otherwise, you can also use the parametric formula or uh, uh, Newton's formula like that. Okay, here look at this little different types of problems. Find the point on the curve y equal to 4x minus x square where the curvature is maximum. Where the curvature is maximum. Curvature is maximum. So, so first you have to find the radius of curvature, because then take the reciprocal. So radius of curvature is this formula, and here you have to find the point. So radius of curvature, if that any point radius of curvature is maximum, curvature is minimum. So that's why it is first find the radius of curvature, and its expression is like this, and it is shown that equality holds for x equal to 2, and this is minimum or maximum value at x equal to sorry, it is minimum. Oh, sorry, curvature is maximum. So you have to find the minimum value of the rho, and the minimum value at x equal to 1. Minimum value is 1, and this minimum value occurs here. Look at this, it is for x equal to 2. So if you substitute x equal to 2 here in the given equation, you will get y, and accordingly you will get the point 24. So minimum at 24, and the minimum value is half. So the curvature at 24 is maximum, and the maximum value is 2. So this is another type of example where you have to first determine the curvature, the radius of curvature, and then from the radius of curvature you have to find the curvature. And the radius of, second look at this, the radius of curvature, this example, radius of curvature of the circle. So here look at this, here it is given in parametric Cartesian form, but it is taken x equal to r cos theta, y equal to r sin theta, which is the parametric form. Why it is taken parametric form? It is convenient to use the formula and to use the differentiation. So that's why it is used this formula. But if you like to use the Cartesian form of the formula, then also it is okay, no problem, you can use. It all depends on your choice, and you must think that which one take more time, because you know that it is a 45 minutes examination, and 15 minutes you will get for uploading, scanning and uploading, etc. So within 45 minutes you have to answer 5 questions. Here the parametric form is used, and if it is given any circle, you must remember the radius of curvature is the radius of the circle. So if you get different result, means there is some mistake. So for any circle, if your question is to find the radius of curvature, first remember that for the circle, radius is the radius of curvature, but you have to evaluate using any formula. And if you get the radius, then it is okay, and if you get some other value, then you must make mistake somewhere. Okay, here the next example is the uh, uh, polynomial curve, and here look at the find the radius of curvature at origin. So from here also you can use the formula 1 plus y1 square whole to the power 3 by 2 by y2. You can use this formula, that is then you have to find y1 y2 at the point 0 0. Otherwise if you would like, then you can use the Newton's formula. So first look at this car passes through the origin, Now what you have to do, find the lowest degree term. Lowest degree term is 4x. If the lowest degree term is 4x plus 3y, then you have to take 4x plus 3y. But here equal to 4x. So x equal to 0. X equal to 0 means y axis is the tangent, and the formula is y square by 2x. If it is x axis is the tangent, then x square by 2y. So then it is divided by, because y square by 2x, as x tends to 0, y tends to 0, then it is rho. So the given equation is divided by 2x, and taking x tends to 0, y tends to 0, you will get y square by 2x equal to rho. So here it is, if you take limit, this is rho, this is rho, this is rho. But when you will take x tends to 0, y tends to 0, then x into rho, x tends to 0. So this term 0, this term 0, this term 0, this term 0, x 0, y 0. So y square by 2x equal to rho. So there is only rho plus 2, that is rho equal to minus 2. But radius of curvature cannot be negative, so rho equal to 2. And here is one polar coordinates is given. You know the formula, and using the formula you can find the radius of curvature. This is one parametric form. Using the parametric form, and in this type of case it is better to use the parametric form only. Don't try to convert it to the Cartesian equation. It will take much more time. You will get the same result, but it will take some time. So I am telling again and again that remember the 4 formulas: Cartesian, polar, parametric, and Newton's formula. Newton's formula you know that very easy. Other formula you have to remember. Here also the problem is same, parametric form. Here find the least value of the radius of curvature. So first find the radius of curvature using the formula. It is this. Now 5 is constant, sec t may vary. Least value means you have to find the least value of sec t. That is 1. So the least value is 5. This is an discussion on the curvature, and you will get question from the curvature. Maybe one full question you may get from the curvature. If you have any question, you may ask me. Otherwise, I will discuss some other things. And I have discussed the mean value theorem. In this chapter, three theorems are discussed. One is the Rolle's theorem, then Lagrange's mean value theorem, Cauchy's mean value theorem, and some problems are solved based on the mean value theorem. There may be question that verify Rolle's theorem for the problem, given problem. One problem will be given that verify Rolle's theorem, means you have to check whether fx is continuous in the closed interval or not, f dash x exists in the open interval or not, or f equal to fb or not. So these are some these are theorems and some questions that I have solved. Verify, for example, verify Rolle's theorem in the plane, Rolle's theorem. So here the interval is 1, 3. Check whether it is continuous or not. Derivative exists or not in the open interval. Fa equal to fb or not. If these three conditions satisfied, then you have to find whether there exists any value of x between a and b at which the derivative is 0, and that is happened here. So the Rolle's theorem is verified, and this value this. Another example is given, verify Rolle's theorem for fx equal to mod x in the interval this, and you know that this mod x is not differentiable at 0, so Rolle's theorem is not applicable. If you can find one condition is not satisfied, then you don't have to check other conditions, then you can say that the theorem is not applicable. And this is the Lagrange's mean value theorem. You know that here also the first two conditions are almost same as the Rolle's theorem, continuous in the closed interval, differentiable in the open interval. The third condition is differ, fa not equal to fb. Here look at this, the theorem gives f dash equal to fb minus fa, fb minus fa by b minus a. If fb equal to fa, then f dash equal to 0. So from the Lagrange's mean value theorem also you can get the Rolle's theorem provided fa equal to fb. And here also I told you that mean value theorem, Lagrange's mean value theorem can be put in this form also, because here usually we consider the interval AB and the difference length of the interval B minus A. Now if B minus A equal to H, that is B equal to AH, the interval is A plus H, A plus H. Then the formula is what? Fa plus H, Fb minus Fa by B minus A. So Fa plus H minus Fa by H equal to F dash C. C is lies between A and A plus H, that is A plus theta H. Theta lies between 0 and 1. And from here you can get this one. Fa plus H equal to Fa plus H F dash theta H. This form is also very important. You must remember this. Sometimes it is very much useful to check the inequality or some other things also. Here it is Cauchy's mean value theorem. Only the difference between the Lagrange's and Cauchy's mean value theorem are that here we have taken two functions, fx and gx. fx and gx. Fx and gx are continuous in the closed interval AB, fx gx differentiable in the open interval, and g dash x not equal to 0. And from Lagrange's Cauchy's mean value theorem also you can obtain the Lagrange's mean value theorem by setting gx equal to x. And here also uh, you here also some examples are solved based on Lagrange's, Cauchy's, and Rolle's theorem. Here also given one example: fx equal to x sin 1 by x when x not equal to 0 when x equal to 0. So that Lagrange's mean value theorem is not applicable. Not applicable means any of the conditions is not satisfied. Any of the condition is not satisfied. So you have to find which condition is not satisfied. First, whether it is continuous or not. Second, whether its derivative exists or not. But here it is found that the function is not differentiable at 0 0. F dash 0 does not exist. So function is not differentiable at 0. Interval is minus 1 1. It contains 0, and 0 at 0 it does not derivative does not exist. So Lagrange's mean value theorem is not applicable.
Sir,
Yes.
sir, in this, when we are checking continuity,
Hmm.
so if we write limit x tends to 0 and the first expression sine 1 by x divided by 1 by x,
Tell me again what?
sir, when we are checking continuity,
Okay.
then for the first line it is written limit x tends to 0 x
Hmm.
sine 1 by x. If we write it as
Hmm.
sine 1 by x divided by 1 by x, then
Hmm. Sine 1 by x divided by 1 by x.
yes, sir.
Uh, just a moment. Sine 1 by x divided by 1 by x. Then
Sir,
what?
then,
Limit x tends to 0.
oh no, no, sir. Then,
It is if 1 by x x tends to infinity, then you can
okay,
say
sir,
sine
okay.
1 by x by 1 by x that is equal to 1,
Okay,
because
sir.
1 by x 0. Okay.
Yes, sir, understood.
Okay. So you again, if you think, I told you that any condition which does not satisfy, if you mention, that is enough. So here, if you just show this portion, then also okay. You don't have to check this portion. Okay. So it is not differentiable. So it is not Lagrange's mean value theorem. You don't have to check whether continuous or not. It is true for all examples. When you will verify some theorems, if any condition is not satisfied, then that theorem does not hold here. And this type of inequality also I have solved some examples. And here look at this. Fx equal to f0, this it is just I have mentioned that Lagrange's mean value theorem f a plus h equal to f a plus h f dash theta h. But here a is taken as 0. Interval instead of a plus h, it is taken 0 x. So it takes the form like this. 0 h 0 h, because you have to find the limit h tends to value of theta as h tends to 0 plus, that is interval is very close, very small interval. And uh, here substituting fx equal to cos x, just use your sense to find the limit. Find the limit. Look at this, sin theta is by theta is h tends to 0 plus. You know that this is 1, because if you take theta is equal to some variable and h tends to 0, then that variable also 0. And here sin square h by 2, sin h by 2 by h by 2, h by 2 tends to 0. That's why this is 1. So you will get this one. Similarly, here some more examples are solved here. Inequality here also, sorry. Here also the interval is this, x by 1 plus x square less than tan inverse x less than x for x greater than 0. The inequality can be also proved using the mean value theorem. Here it is used Lagrange's mean value theorem. In some cases it may be Cauchy's mean value theorem, etc. But this choice of here, look at this, the function is fx equal to tan inverse x. This choice is also important whenever you will check this type of inequality. One more three more examples are given, and it is for your calculation.
Sir,
Very, yes.
sir, in last examples, sorry, last year example, sir, f of x is
Hmm?
equals to sin x. Sir, I had
Hmm.
solved, but actually we
Not
come
getting
across a
result.
step. But sir, I'm not getting the result actually, sir.
Okay, so it is probably in this tab. I will show you this example. I have solved. Uh, I will upload in your classroom, because those who are trying to solve this and not getting result may get the result.
Thank you, sir.
Today I will, after this class, I will upload the problem. This
Okay,
one,
sir.
the last one. But probably the earlier one, the first one and the second one, I think it is not so difficult. So I will upload the third one. Here also, here and there, some different examples are given, and these are this last example. Look at the expand log of 1 plus x in the interval minus 1 less than x less than equal to 1 in ascending powers of x in infinite series. And I already told you that whenever you will going to expand the function in infinite series, first you have to check whether the remainder after n terms, that is Rn tends to 0 or not. Rn tends to 0. If Rn tends to 0, then only you can get the infinite series. So first you have to check whether Rn tends to 0 or not. And in that case, when you are trying to check whether Rn tends to 0 or not, usually we prefer Lagrange's form of remainder, because it's simplicity. Lagrange's form of remainder is simple than Cauchy's form of remainder. But in some cases, using Lagrange's form of remainder, checking whether Rn tends to 0 as n tends to infinity is not easy, and sometimes it is not possible. Then you have to use the Cauchy's form of remainder. So both the remainder you must remember the form of Cauchy and both Cauchy and Lagrange. The question may be because if you try to expand it, it will take time. So the question may be just for the function this log of 1 plus x in the interval minus 1 less than x less than equal to 1, find the Lagrange's form of remainder. Then you just write the Lagrange's form of remainder, but you have to differentiate n times nth order derivative, then you have to find the Lagrange's form of remainder. Similarly, question may be just find the Cauchy's form of remainder. Then you don't have to expand the function, you don't have to check whether Rn tends to 0 or not. You don't have to check. Just write the if it is Lagrange's form of remainder, then write the Lagrange's form of remainder. If it is Cauchy's form of remainder, just write the Cauchy's form of remainder based on your function. Based on your function. If function is log of 1 plus x, then based on this function, write the Cauchy's form of remainder. These are some the proof of all these.
Sir, the proof of Taylor's theorem with a Lagrange's and Cauchy remainder are quite confusing, sir. Can you please discuss a little
Cauchy,
bit?
which one?
Sir, Cauchy is and Lagrange's remainder.
Confusing.
Yes, sir. Sir, derivation. If you please
Uh,
discuss, sir.
but for this, I will discuss no problem. But for this midterm examination, uh, you can avoid the proof of Taylor's theorem. Just remember the Taylor's theorem with Cauchy's form of remainder and uh, uh, Lagrange's form of remainder.
Sir,
Okay.
will
For
they are asked in examination about the proofs or derivations, like derive the Taylor's theorem like this?
it may be it is not that proof will not be considered only the examples or uh, only the remainder etc. But you know that this time it is only the 45 minutes paper. So uh, so the long proof, mainly the Leibniz theorem proof, mainly the Taylor's theorem proof, is you may avoid this time the proof of this Taylor's theorem, Lagrange's
Okay, sir.
sorry, Leibniz theorem, mm,
Okay, sir,
and
understood.
which one other proof? Any other proof? Lagrange, Leibniz, Taylor's. These are long. So you may avoid the proofs for these theorems. But remember the theorem statement is very much important, because when you will solve example, you have to use this one. Suppose there is, if there is any question that write the Lagrange's form of remainder in Taylor's expansion, you have to write that only the form. Write the Cauchy's form of remainder, then you have to write the Cauchy's form of remainder. Okay. So for this exam, you may avoid these proofs, long proofs.
Okay, sir, understood.
Sir,
Yes,
I am stuck in a problem, sir. Means I am not able to solve a problem.
which one?
So, sir, means can I share my screen, sir? So can I show you the problem?
You can show. Then I have to stop here. Just
Oh,
Which problem? On which topics?
Sir, it's from successive differentiation, I think.
Okay. If any others are also interested, then you can show.
Yes, sir.
Sir, is my screen visible?
Screen visible, but nothing is appearing here.
Sir,
So in landscape mode, rotate the mobile. Yes.
is it visible, sir? This is the question.
Fx equal to 10x.
Yes, sir.
Okay. So what is your question?
Means, sir, I am not able to prove this equation.
But probably I have solved this example. If I am not wrong, then I have solved it. I will check. Probably I have solved this example. Fx equal to 10x. It is what you have to do. Fx equal to 10x, then fx equal to sin x by cos x, then take fx into cos x equal to sin x. Okay.
Yes, sir.
Fx into cos x equal to sin x. Then use the Leibniz theorem. It is nothing. I am giving hints. So stop your presentation. Then I will show you how to proceed.
Then, sir, there is one more problem, sir. This question number 14.
If a equal to -1, b greater than equal to 1, a equal to -1, b greater than equal to 1, and fx equal to 1 by mod x, prove that Lagrange's mean value theorem is not applicable for f in AB. -1, b greater than equal to 1. B greater than equal to 1. Okay. So start from -1, b greater than equal to 1. And interval is AB. Fx equal to 1 by mod x, prove that Lagrange's mean value theorem is not applicable for f in AB, but check that the conclusion of the theorem is true if b greater than 1 plus root 2. Conclusion of the theorem, Lagrange's mean value theorem is not applicable for AB. So check whether the function fx equal to 1 by mod x, is it continuous in the interval AB? Is it continuous? Interval is, suppose b equal to, for example, b equal to 1. So interval is what? -1 and 1. Is it continuous in the interval -1 1?
No, sir.
Where it is discontinuous?
Zero.
So Lagrange's mean value theorem is not applicable.
Yes, sir, but in the second statement, when b greater than equal,
But check that the conclusion of the theorem is true if b greater than 1 by 1 plus. So what is the statement of the theorem? Fb minus fa by b minus a equal to f dash c. Okay.
yes, sir.
So from here, try to find that fb minus fa, but check that the conclusion of the theorem is true if b greater than 1 plus root 2. B greater than 1 plus root 2. So I have to check whether FB minus FA, that is FA means minus 1, F minus 1. So minus 1 means here it is 1, that is 1. Okay. So FB equal FB minus 1 by B plus 1 equal to F dash C. I have to check whether it is true if B greater than 1 plus root 2. I have to check because B greater than 1 plus root 2, that is FA. I have to calculate it.
Means, sir,
I will check it. Hmm.
sir, in this second statement, the
Hmm.
interval will be, sir, a to b, but the, sir, value of here a is minus 1 and b is greater than
Hmm.
1 plus root 2. So, sir, 0 will be between the interval, sir. Means in the interval.
No, actually, as I understand, they are not asking you whether Lagrange's theorem is applicable or not. Just the final result is what? Final result is FB minus FA by B minus A equal to F dash C. You you have to uh, uh, check the last portion only. Forget about anything, whether it is the Lagrange's mean value theorem or whatever it may be. the Just think about the problem FB minus FA by B minus A equal to F dash C. This is given. Now check whether in the interval A and B, when B greater than 1 plus root 2, whether it is applicable, that you are getting B greater than 1 plus root 2 or not. I think so, because here if you consider the interval A minus A equal to minus 1 to B, and if you are checking whether Lagrange's theorem applicable or not in that interval, then it is not applicable because it contains again 0. So it is not continuous. Because if it is true, then in the first part, prove that the Lagrange's mean value theorem is not applicable for f in AB. This is also not whole because b equal to 1, b greater than 1 plus root 2. Then also it is the same as in the first case.
Yes, sir.
B greater than 1 plus root 2 means it is also b greater than equal to 1. So in the first case, why not Lagrange's mean value theorem is not applicable? So I think as I understand that it is not asking about the whether Lagrange's mean value theorem is not applicable or applicable for b greater than 1 plus root. It is just the in the last case, in the last where the conclusion of the theorem is given, that is fb minus fa by b minus a equal to f dash c. It is actually, I think, asking only that question.
Okay, sir, understood, sir.
Okay. Because if you consider b equal to 1 plus root 2, then and checking Lagrange's mean value theorem, then it is, you don't have to calculate anything, you can say it is not applicable because it is 1 by mod x and at it contains the interval, it contains the value 0, so it is not applicable. Okay, so this is one, and
Hello, sir.
probably yes.
Hello, sir. I also have a problem with understanding a part of a problem in linear differential equation, sir. Can I show?
Differential equation,
Yes, sir. Linear differential equation. I can't
linear
understand it.
differential equation, then you have to ask your teacher who is taking the class.
Actually, sir, before exam there is no class. Actually, in the last class,
Okay, you
madam.
can show me, but I would suggest you that if you have any question relating to other topics, you will ask. Okay, so show me,
Okay, sir.
because I can say something, then he will tell that his approach is different. Then he may ask why you have mentioned here is this. Like that. Okay, show
Sir, is
me.
it visible? Hello.
Visible.
Mm. like sir, here
Hmm.
when
Hmm.
sir here two roots are of a equal auxiliary
Hmm.
equation, that is m1 equal to
Hmm.
m2, then sir,
Hmm.
this is the equation, like this is here if
Hmm.
m1 equal to m2, we take common for
Hmm.
e to the power m1x, then
Hmm.
from where sir this extra x comes with c2, and in the
Oh,
next line sir, m1 equal to m2 equal
hmm.
to m3, extra x
X
square
square.
sir where comes
X
sir,
square
from
is
where?
also X square is also coming. Oh,
Yes
you
sir.
will not get, you will not get from here. Okay. So it is also, you can suppose if m1 and m2 are two equal roots, then it comes from other things. I think here no proof is given. No proof is given.
Yes sir, it is just written that case 1,
Hmm.
auxiliary equation, it says auxiliary equation,
No.
then
I
case
am not
1 m
asking
equal to
that proof.
m2, no proof sir, no proof,
Uh, no proofs
just
are
using
given.
it.
Oh, that's why it is a problem. But uh, if two roots are equal, it is in our theory also. If two roots are equal, say for example m1 m2, and if three roots are equal for one m1 m2 m3, then it is x up to x square. If four roots, then up to x cube, like that. If roots are equal, then we can prove that, for suppose m1 and m2 both are equal, then e to the power m1x is a solution, and in that case it can be shown that x e to the power m1x also a solution. And when we are considering general solution, then c1 of the first solution, c2 of the second solution. You know that if A is a solution, B is solution, another solution, C is another solution, D is another solution. Then their linear combination is the general solution. That is C1 into A plus C2 into B, C3 into C, C4 into D, general solution. Here, here the proof is not given. That's why some confusion is arise. But don't worry, you no need to give the proof in your exam. Just if you just try to understand why it is happening, then I can say that if suppose I am considering only the two roots are equal, that is a lambda equal to m1 m1, then e to the as per you have assumed the solution e to the power m1 mx,
Yes
so
sir.
e to the power m1x is a solution.
Yes.
Yes,
Huh.
then it can be proved that x e to the power m1x is also a solution. It is in every differential equation book. It is all these are shown. X e to the power m1x is also a solution.
Okay
And
sir.
since e to the power m1x and x e to the power m1x both are solution, therefore the general solution is c1 e to the power mx plus c2 x e to the power mx.
And then if say three roots are equal, then x
Three
square e to
roots
the
are
power
equal.
m1x. Yes.
If three roots are equal, say suppose m1, 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 then it can be shown e to the power mx is a solution, already you have got. X e to the power m1x is also a solution. X square e to the power m1x is also a solution of the given equation.
Okay sir. Like it is
So three
following a pattern,
solutions.
1 plus x
This
square, like this.
it is if there are 100 roots are equal, 200, any finite number of roots are equal, then it will follow this pattern. C1 plus C2x plus C3x square, C4x to the power 4, like that.
Okay sir.
Whatever it may be the number of roots, it will follow this pattern.
Okay sir.
Okay. So if you need any more discussion, we may continue. Otherwise, we may stop. And one question who asking me that fx equal to tan x, as I understand that I have solved this example. If not, then it is just take fx equal to tan x, means fx equal to sin x by cos x, then it is fx cos x equal to sin x, fx cos x equal to sin x, then use the Leibniz theorem. You will get this result, and then take x equal to 0. In the right hand side, sin x, nth order derivative sin n pi by 2 plus x, and if you set x equal to 0, sin n pi by 2, and in the left hand side, fx into cos x, u into v, use the formula Leibniz theorem, then set x equal to 0, you will get the result. 3-4 lines problem, very simple problem.
Understood, sir.
And the questions are not so difficult. Simple questions are in your midterm exam purpose, for simple questions are given. Just if you practice, know some formula, you can easily get the formula, because remember that time is only 45 minutes. Within 45 minutes, you have to answer 30 marks. And also, infinite series, some questions of infinite series also given. And I think it is not so difficult. So just you know the formula. Formula means ratio test, root test. Just use those tests. You can get the conclusion whether it is converges or diverges, or interval of convergence or interval of divergence. Suppose for example, un plus 1 by un as n tends to infinity, and this after taking this ratio and taking the limit n tends to infinity, suppose x equal to, it is x, then what will be your conclusion? If x less than 1, greater than 1, and if x equal to 1, no conclusion can be drawn from here. You have to, how many questions there are? 7 questions. You have to attempt 5 questions, and first 5 answer will be evaluated, because it is online checking. That's why we are considering only the first 5 questions. If you have answered 6 questions, then we will check only the first 5 questions. Remember this. So you will get 2 more options, no problem. And I think no options are needed. Questions are so easy.
Like sir, in the first 5 problems, if we get one is wrong, like number 5 or number 4 is wrong, and later we give number 6 or number 7 correct, like we'll
Then if it is wrong, then cancel it.
okay sir, then we should cross it totally, then next problem. Okay sir.
If you know that it is wrong, you have made mistake, or finally you decided that it is better to uh, it may be better if we if your 7th answer is you chance of getting more marks, then cancel any one, which one you think that it is not so, may be wrong. Okay, so since we are now checking answer script online, so it is difficult to follow in this way. That's why we are considering only the first 5 questions. If you cancel, then we will not consider it as one answer. Okay, then okay. So no problem. Just practice the problems of Leibniz theorem. Practice the problem of the curvature. Uh, because no derivation of the formula, etc., this time we are not giving. And Taylor's Leibniz mean value theorem. No proof. Only the statement you must remember. Otherwise, you cannot attempt the question. And who asked me that the sin x for the fx equal to sin x theta tends h tends to 0 theta will have. I will just after the class I will upload this one. Okay.
Okay, sir.
Okay, sir.
Okay, sir.
Okay. And probably your group 5, no, today group 5, and probably I am the coordinator for the group 5, so I will be present during examination also.
Okay, sir.
Okay.